Yeah, so in this particular case, what I'm thinking in the approach which I'm thinking is because I am given the root node as input, and these values on the each node are the values, actual values for which I have to find the maximum sum.
Mm-hmm.
So what I'm thinking is I have eventually three cases for each node. Like starting from root, I'll go to all the nodes. I can do basically maybe in pre-order traversal. I'm thinking. So
Mm-hmm.
first I will check if that node gives me the maximum sum. I'll keep one maximum sum variable outside this function as a global variable. That's
Why
what
do you
I'm
need
thinking.
global variable? Why are you suddenly saying global variable?
Uh, just to, yeah, I think why I was thinking is because I was thinking the sum could be sum of only that node could give me the maximum sum. That node plus left node. So now there will be something coming from left and right. I can
Mm-hmm.
do a tree traversal in a maybe pre-order fashion. Maybe I'll just give a second thought to the global variable. Can I just hold on for a second on that
Sure,
part?
sure, sure, sure.
Okay, so I was just thinking I'll do a pre-order traversal and I'll go to the root of the root. If the root gives me, now there are three cases. A root can give me maximum sum, or there are two things coming from left and right because I'll get the sum from left and right also. As soon as I see a leaf, I'll return that value. Leaf means left and right both are null. I'll return that value as a sum. So there'll be some sum coming from left, some sum coming from right, and now there are three values I have essentially at each node. One
Mm-hmm.
is that node, one is the sum from the left, total sum from left, total sum from right. Now the comparison which I want to do is, now only root could be the maximum, right?
Mm-hmm.
Or only left could be the between left and right there will be one maximum, or root plus left plus right could be maximum if all are positive, right?
Okay.
Root plus left plus right could be maximum. That is one evaluation I need to do. Only root could be maximum. Then I need to take the maximum between left and right and add it to the root. So that also could be maximum. Like root added with the left node only or right node only. In case one of the sums is negative, let us say from left side the sum is coming as negative, root is positive, right side sum is positive. So root plus one of the sums could be maximum.
Okay.
So I'm thinking only of three evaluations. Maybe I'll explore on the way if more evaluations needed. So that ways, if I'll return whatever maximum I find, I'll return at each node. I think in that case I don't need a global variable because at each node I can evaluate and return it, and I have to traverse each node once and only once. I think on, if there are any number of nodes in the tree,
Mm-hmm.
I think I can do it in on starting from root. I'll go to all the leaves in a pre-order traversal fashion, and while coming back, I will evaluate these sums. Does it sound like a okay approach to you?
Yes, yes. Sounds good.
So let
Assume
me.
that you already have the node. Okay. Just complete
I
right
have a,
function. You have the. Should have something like this.
yeah, public. So can I assume the sum is in integer range only,
Yes,
or should
yes.
I take long or something?
Int is fine. That's okay.
Int is fine. So
Parameter is good
max.
node.
So
Parameter is
yeah,
good.
so get max path sum, and uh, tree node is the yeah. So I have root as the input here. So this is the input function given to me. Uh, so I have an integer. So now what I want to find is I want to traverse in a pre-order manner and get the left right. Okay. So I think what I can do is I think in this only if the just some boundary cases if the root is null, then I'll return zero. There is nothing. So max. Can I assume that if nothing is there, can I return zero? Is that a fair assumption?
Yes.
So then, what I want to do is I can just uh, so root left right. Okay, so I think I can get a I can get a traversal on the same function. Um, So I'm just assuming that the tree node class, whatever I'm taking, so tree node class looks like this. That is the assumption I'm taking. So my tree node class is something like it has one integer val, which is the value, and
And left, right.
and it has
So
left
assume
right.
that. Don't spend your time on that. You have
Okay,
left and right. Okay.
okay, left and right, yeah.
Left and right.
So
So
so here I'm evaluating left sum. So what I will do is here I'll pass root dot left, and here I'll get before getting left and right, if root dot left and right, root dot left, so root dot left is null, and root dot. I think I'm specifically evaluating a leaf node here. Even if I don't do it, it should work. But I just want to save one extra, on the leaf node. It will go check that extra check. I want to do it
okay.
prior to that only.
Mm-hmm.
So if left and right is null, I will return the root dot val, basically actual value. So for example, I reached 5 here,
Got it.
left and right
Got it.
null, so I'll
Got
return
it.
5,
Got it.
8,
Got it.
like that.
Continue. Continue.
So that is one check I'm doing. Then I'll say right sum. My right sum is this dot right. Now I have three things. So here I will pass right. Now I have three things, and let's say if only one side is null, one side is non-null, then this condition will hold true, and it will return 0. So now if I have now root val left and right. So what I said is, so I'll just take one variable called max sum. So I'll just do the comparisons. What I said, only root, or only node, basically current node, and that is one thing. Um, so I'll assign it to only current node. Then so I'll assume first the max sum is 0. So can we have a negative sum also as a max sum?
Can you please more specific on your question?
So can all the nodes be having negative value? Is it possible?
It is possible.
Okay, then what I will do is I'll say root dot val. I'll assign this. I'll assume this is a max sum. Now I have to evaluate this only, and this with this plus left plus right. So what I will do is max sum is equal to math dot max of existing max sum, which is root value, with root plus left sum plus right sum. That could be one evaluation. Then whatever max sum comes, I have to evaluate it with uh, uh, maximum of left and right only. That is another evaluation. Left sum, comma, right sum, which could be another evaluation. So only root could be maximum, which I have taken here. Root plus left plus right could be maximum, which I will evaluate here. And if some of the sums are negative, then minimum of these two adding to minimum of these two adding to root, actually adding to root dot val uh, could be maximum. If some one of the sum is negative, one is positive, you know. Or there could be another case if root is negative and one of the side is negative, only my right side is positive. So that case also could be there. So then I have to evaluate that also. Uh, so that case could be maximum of these two. I think it has taken care of all the cases now. Now whatever maximum I find, I'll just return it. And I think that should be fine. And like in the calling program, it will return the maximum sum. Shall I run some use case on this?
Mm,
Whatever example you have given, first example.
yeah, can you do it first? That clear karna.
First one is it 1 to 6?
Yeah, try with all examples. See it's working or not.
So yeah, so first I'll pass 1. So 1 goes here. Now it is not null. It has left, right, not null. It will go here. Then it will call left. Left means it will call 2. On 2, when it goes to 2, 2 has left and right null. So 2, it will return 2. So this guy, left side, will return 2. And when I go to right side, then right side is 6. Then 6 will again have a recursive loop. 6 has both left and right null. It will return 6. And now I will start with root value. Root value is 1. So then I say, hey, 1 and 1 plus 6 plus 2, 9. So here the maximum will become 9. And here I will say, hey, existing 9 has to be done with root plus maximum of left plus right. Maximum of left plus right is 6. 1 plus 6, 7. Now 9 and 7 is 9. Again, here it will be 9. And then I will say, hey, max sum whatever I have so far with maximum of left or right, 6 or 2, 6. So 9 and 6 compared, it will be 9. So here it will be 9.
Mm.
Then max sum returned will be 9. Is it correct? Output 9.
Yeah,
Yeah.
yeah, it will work. Yes, the first tree will work. Yes.
Okay. So you want me to check any other case?
Yes, can you try the second one? Let's see it's working or
This
not.
minus 9 one? This one?
No, a second one. Go to the second tree.
Okay. Yeah. So 16258, that is 19. Okay. So I think now one in the second case it will go to 1. 1 has left and right both present, so it will go to 2. 2 will return 2 because left and right are null. It will return 2. Then it will go to 6. 6 has both left and right present. 6 will again go to recursive loop. So here basically, so I'll say comma recursive loop of 6, recursive of 6. So recursive of 6 here in the left side, it will be 5, it will return 5. And recursive of 6 on the left side, right side will return 8. So 5 plus 8. So it will return 5 and 8. And this value is 6. 6. Then left is for the time being I'll just remove this 2. This is at upper level. So
Okay.
this is 5. At 6 level it is 5, it is 8. This is 6. Now I'll say, hey, 6 is greater than 6 plus 5 plus 8. 5 plus 8, 13 plus 6, 19. 19 and 6 compared, it is 19. So it will say 19 here.
Mm-hmm.
And then he'll say 19 I will compare with the root value is 6. 6 plus maximum of any of the two nodes, 8 or 5. 6 plus 8 is 14.
Mm-hmm.
So 14 and 19 compared, 19 will be maximum. And here I will say, hey, uh, I will compare the maximum, which is 19 so far, with left or right, which is 8. So 19 and 8 returns me 19. So this loop of 6 returns me 19. So it means here in the top level, when I'm at that one root level, right? So left is 2, right returns me 19, right?
Mm-hmm.
So it returns me 19. Now here, okay. So the path cannot have, okay, this is an issue. So path cannot have this.
Yes.
Okay, so I have an issue here in the algorithm
Mm-hmm.
because the path, when I propagate up, I have to propagate only one side. I can't propagate both the sides.
Okay.
So either this root plus this is maximum, which is fine, which is applicable only for this level. But when I return something, that return has to be this root plus left plus right is good for this guy, right? So then I think I need a outside variable
Okay.
global variable for preserving uh, uh, overall max path sum. So I have an issue here. So overall max path sum I will assume to be integer minimum value, because the values can be negative also. So is
Okay.
it a fair assumption?
Yes. That's okay.
Okay, so then I think while returning, I have to return by pairing the node with either left or right, or the node alone. So
Mm-hmm.
this sum, whatever I find, so this actually, I will not take it as a part of this guy. So when I'm sending the things up, this I will do later. So when I'm sending the things up, I have a max sum, either this value or this plus max of left right is what I can send up. So
Okay.
this max sum I can send up. When I send this, this will be the max sum sent up. But overall max sum, this alone, or this plus sum of left plus right, this alone, or this plus sum of left right, whatever is maximum. Yeah. So because path sum will be 6 plus 8 or 6 plus 5 when it goes up, or it could be only 6 if both are negative.
Yes.
So that's what I'm doing. So this is what I'm returning. But for overall sum, overall, we'll also have one more thing. Overall, I'll say, hey, math dot max overall sum, comma max sum so far. Whatever is overall sum, compare it with max sum. That could be the overall. Other thing could be the one which I deleted. So that I have to do for overall sum. If this is a whole path, 5, 6, and 8 is the whole path. Okay.
Mm-hmm.
So that I have to do here, which means root dot val plus left plus right, basically. If this is the overall sum. So left sum. Okay. So root dot val plus left sum plus uh, right sum. That could be one thing which will be overall maximum, plus it could be any one of them also. uh, okay, this I have already taken care here. Root plus one of them I have already taken care here. So I have root plus one of them I've already taken care here, alone root also. So this is not required. So overall max sum I have here. Then in that case, my return will be max sum. So I need to take another function. So let me take a util function here. So this is a function which will call a util function. So private int get max path sum util. So in this case, I will pass a tree node only, which I'm just giving the name as root for now. I think I can change the name to node as well. So this guy will have everything, and but here I will get the max path sum util. I'll call it. It will be useful for all other cases. Root. Uh, The only thing is now if the root is null, here I'll handle a special case. If the root is null, I'll return 0. I'll return 0, and I'll call this, and I'll return overall max path sum. So when I call this, it can still be possible that uh, if the overall max sum is still integer min value, and return 0, otherwise return the overall max path sum. So in this case, the global variable will basically, because at each individual node level, I have to return this max path sum, which is either this node or this plus left or this plus right. But the overall max path could also be this path, 5, 6, 8 as a path. So for that, I think I need a global variable, and this global variable will consist of the answer. And if this global variable is still not filled due to some reason, I'll return 0. Otherwise, I'll return this global variable. Does it make sense?
But what reason do you think?
For
No, you're checking the conditions, right? That overall path sum equal
Mhm.
to min, line number 14. I'm just
Line,
thinking in which case you will encounter that.
equal to minimum value.
You're checking, right, line number 14.
So if my root is not null, but other things are, yeah, I think it will not come because root null I'm checking here only. Only that was a case where it could remain in its original value.
Okay,
Otherwise, the value will definitely get changed,
okay,
and
fine,
I can return only that one. I
fine.
think.
Now will it work for all use cases?
Should
What
we
do you
try? Should we try?
mm,
We
yeah,
should.
it will work. It will work. But can you try to remove some dead code?
Yeah. So dead code here is this is fine. So here the dead code will be root dot left, root dot right is fine.
Hold, uh, 1 second, 1 second. Hold on. I'm just thinking. mm, I
So,
think I can check. It's work for all cases. Check again. I'm thinking it will. Some use cases will fail.
so here if the root is null, I will return a minimum value here. I think that is one change I need because some negative value may be the highest. If all values are negative in the tree and I return 0, the sum returned will be 0, but it should be some negative value, right? So if let's say this 2 is not there, this 2 is null, right? So my code is returning 0 there, and if all other values are negative, -1, -6, -5, -8,
Mm,
then probably -1 is the answer. That is the highest sum for individual node or path, right? So my code will return 0 because it is assuming if I reach null, I have to return 0. So I
correct.
will return a minimum value here to make sure all negative node cases are also taken care. Is it fine?
Uh, Still right. Check some use cases. It will work or not.
Okay, let me take another use case. What you have given?
With simple tree, you can easily do it.
Yeah. Okay, left, right is fine. Then I'll assume it is this is a maximum. Then this plus left or right. That I will evaluate, and I will check this with this thing, which is fine. Then I'll propagate the maximum sum, and I will also check it before propagating. I'll also check it with the sum of all three. I think there is no dead code, at least in this one. There might be a
Okay, forget about it.
this
Code.
might be a dead code. If I take it out, it will work, still work, because it will go one level down and it will be null. It will return minimum, then it will be like 15,
Okay.
minimum. Out of 15 minimum, it will say 15, then 15 plus this max of these two, which will be minimum value, then 15 is maximum, so it will say 15. And then yeah, it will work. The only case is I am doing a sum here, sum of minimum plus something. Okay, should be fine. Plus minimum, I don't know whether it will be fine or not. I want to put a check here. If my I'm not sure if the code will break if one side or both. If I remove this also, it should work. The only case is but if I keep it, only case is I'll detect it earlier, the leaf nodes, and that integer minimum case will not lead to integer minimum plus integer minimum. Here, if I remove this code, considering it as a dead code, it may result in a case when both the nodes are null. For case 15 node, both are
Still have
null.
a
It will
dead
be
code,
minimum
right?
minimum. Huh?
No, hold on. This is not a dead code, right?
Yeah, this
Line
is
number
required.
21, 22 will be executed, right?
Yeah, it is required. Yeah, that's what I was just thinking.
No, no,
What
no.
could be the dead code
Hold on.
here? Yeah.
We are confusing multiple problems. One thing is, I have two questions. I asked two questions. I first asked to remove that code. Then I feel that some use cases will not work. Okay, so some use cases will not work. I identified that first. Hello.
Okay. Yeah, yeah. I think your voice was breaking,
Okay, can you?
but I got it. So you're saying some use cases will not work.
Yeah, fix it with the current code.
Yeah, I'm just thinking which use case will not work. So shall I try this use case?
Yeah, that will work.
That will work.
Some
No.
maybe you take a simple tree with all possible combinations.
Yeah. So simple tree will all possible combinations will be left, right. One minute. So what all combinations are required? So see, either left plus right plus that node, that is one combination which I've already considered, or root plus either left or right, that I have considered here, or only root, that I have assumed here in the beginning, only root, this is I've considered as maximum. Then this I've compared with one of the nodes, sum with one of the nodes. So that is here, that I am returning because it is one line I am returning, like 27 or 2015 or only 20. All these three will be taken care by these first two things which I am returning. But there is one other use case which I need to check is sum of these three, 20 plus 15 plus 7, that I am doing here. And there is one more use case which I need to check here is whatever this guy I am returning, this could be the maximum 20 or 20 plus 15 or 20 plus 7, that I am already checking here, overall path sum with max sum. So I think all cases are covered. Not sure if anything I'm missing here. Can we please point out some example which will not work
Okay.
here?
Okay. Fine. I will tell you. One second. Just check whether this will work.
Okay.
Same tree, right? Will work. For this,
Yeah.
what is the output?
So you have pasted it somewhere?
This
One minute. I think in the message
first one,
chat.
right? I mod.
Okay. First
No,
one.
no,
Yeah.
no. Yeah. Go top. Go to the top. Yeah. What is the output for the first one?
The output for the first one should be 6. It should be 6 actually.
Correct.
So I am doing,
Will it work?
okay. Only left right. So only left right I am not comparing. So that only left right comparison has to happen here. Yeah, you're right, I think. So the only left right comparison, no, I think 1 minute, 1 minute. So if I go this, right, let us take only this one,
Hmm.
right? So I go to -1. So -1 has left is null, which will return a minimum value. So here
Correct.
left is return a min value. I'm writing short as min, and right will I will go to right. Right will return me 6 here.
Correct.
Right will return me 6 here. Then I come here. I
Correct.
assume max sum is root value, which is -1. That is first assumption. Then I compare that with
Yes.
-1 with the
Yes.
-1 with the -1 plus max of these two, which is 6, which is 5. So I'll say, okay, max is 5. Here I will have a max as
Correct.
5. Okay, and then overall sum, I will say overall sum or max overall sum is minimum or 5. Then I will say overall sum is the root plus left plus right, so that anyways will be of some negative value. That will not work. So I have to take care of one more comparison. So overall sum has to be compared with the max of these two. So which is thanks for pointing out that bug in the code. So what I have to do is the overall sum. So if I remove this guy, right, that should be taken care of. But I think I can also take care of that one by doing a max of left right here, because max of left right alone could be a this thing, because that is not counted as a node because of this guy. If I remove this, that will be taken care of, because this will be counted as a
Okay.
valid node which has left and right. That will be taken care. So you want me to remove this code or do a max of left right here, because that max of left right only makes sense for leaf nodes. For intermediate nodes it doesn't make sense, because intermediate nodes would have been checked as individual nodes at some point earlier. So if I remove this code,
Mm.
this will be taken care, I believe. Let me try it out again. So if the root is null, root is not null, it will go here. It will go to left, which returns me min. It will go to right. Now right further will
Yeah,
go.
that will work. That will work. The only problem you
Yeah,
have is that
yeah. On the
line of
leaf nodes,
28.
I was returning a value which itself was not taken as an individual node. So thanks for pointing out that mistake.
Okay. One my last question for this one.